In this lecture, we will introduce the notion of polymorphism. One of the features of Java that we haven't talked about yet is that it allows us to treat an object of a subclass as an object of its superclass. So in other words, a reference variable of a superclass type can just point to an object of its subclass. And I might think, shouldn't it be the other way around? Shouldn't we have the reference variable of the subclass point to an object of the superclass? No, we actually want the other way around. So we create a reference variable of a superclass type, and it can just simply point to an object of the subclass. Why would this be useful? Well, what we'll see is that there are situations where this feature of Java can actually be used to develop what we call generic code for several applications. The idea behind generic code is I can write a class or a method, and I'm not limited to the data type or the return type because it could be based on what we bring in. We saw some examples of generic code or generic methods when we talked about the math class a long time ago, like with the absolute value method, for example. The return type was based on the parameters that were being passed. So if we brought in integers, it returned an integer. We're talking about something similar here where we're not limited to exactly what types we're dealing with. Let's take a look at an example of this. So let's say we have the following code where we're declaring some reference variables and we're creating some objects of these classes. So the first line, we're declaring name and nameref to be reference variables of type person. The second line, we're declaring employee and employee ref to be reference variables of type employee. Now here we're assuming that employee is a subclass of the person class, or employee is inheriting stuff from the person class. So here we'll say that we're inheriting the first and last name of a person. The third line is creating an object of the person class. So here the first name is going to be John, the last name is going to be Snow, and we're going to store that object in the name reference variable. And then the next line, we're going to create an object of the employee class. So we're going to have Rick as the first name, Grimes as the second name. And notice that we're going to include some additional information. We're going to include the wage of the person and the number of hours worked per week. So here we're also going to say that the wage is $12.50 per hour and the hours worked is 45. So here we have all that's being stored in the employee reference variable. Now let's take a look at the following statements. So the next statement, this nameref equals employee, what that does is it makes nameref point to object employee. So what happens is after this line executes, the object nameref is being treated as an object of the employee class. And what that means is the next statement, when we're printing the value of the object nameref, it's actually being treated as an object of the employee class. So when we call the toString method, we're not calling the toString method of the person class, we're calling the toString method of the employee class. What that means is the output is going to be nameref, then the colon, and then we're going to output the information from the employee object, which in this case is going to be Rick Grimes. And here we're assuming that we multiply the wage with the number of hours, so that would be 562.5. So in our example, notice that even though nameref is derived as a reference variable of type person, when the program executes, the print statement actually outputs the first name, the last name, and the wages of the employee. And this is because whenever we execute that print statement, the toString method of the employee class is being executed instead of the toString method of the person class. I know I already mentioned it, but that's what's actually going on here. And this is actually what we call late binding, dynamic binding, or runtime binding. I'm probably going to use late binding for the stuff that we're talking about here. So what is late binding? Well, what we're saying here is that the method that gets executed is determined at execution time, not at compile time. So whenever we're calling the toString method, while the program is running, it determines whether to use the toString method from the person class or the employee class. So that's great now, but what do we mean by binding? Binding just simply means that we're associating a method definition with its invocation. So we don't really map the method call with the method definition until we would actually run the program instead of compiling. That's what we mean by late binding. Binding just simply means that we're mapping the method call with the definition. So whenever we make the call, we know exactly which definition to go to. Now there is another type of binding which is called early binding. And this just means that the method's definition is associated when the code is compiled. So instead of doing it at execution time, we would associate the method call with the definition at compile time rather than execution time. Some languages do use early binding. Java is one of those languages that uses late binding. So Java is going to map the method call with the definition while the program is running instead of when it's compiling. In a class hierarchy, several methods may have the same name and the same formal parameter list. This is not as uncommon as you think. Also, a reference variable of a class can refer to either an object of its own class, or it can refer to an object of its subclass. So we have reference variables that can refer to either one. So therefore, this means that a reference variable can invoke, or in other words, execute, a method of its own class, or it can execute a method of its subclass or its subclasses. So this is where we get to this whole binding thing that we just talked about, where we're mapping the method call with a particular meaning. And this all comes down to what we call polymorphism. So the idea with polymorphism is that we're associating multiple potential meanings with the same name. And this is done in Java by using late binding. Now we have these reference variables, which means that they can have multiple forms. So we say that reference variables that can have many forms are called polymorphic reference variables. These can refer to objects of their own class or to objects of the subclasses inherited from their class. So from our earlier example, the reference variable name or nameref can actually point to an object of the person class, or it can point to any object of the employee class. Let's use our rectangle and box classes as an example. So remember, we have the rectangle class, which specifies the length and width of a rectangle, and then we have a box class, which is the subclass of the rectangle class, which not only has the length and the width, but it also has the height of the box. So here we create reference variables rectangle and shaperef, which are going to be reference variables of type rectangle. And then we have box, which is a reference variable of type box. And then we see that we create the rectangle and box objects, and we store them in the rectangle and box reference variables respectively. So what we have here is that shaperef is a reference variable of type rectangle, but we can point to an object of type box because box is derived from rectangle. So let's say we have the following lines of code. So here we're going to take rectangle and store it into shaperef. So what this is saying is shaperef now is pointing to an object of type rectangle, which doesn't seem out of the ordinary because shaperef is already of type rectangle. So this first print statement here, the system.out.println, when we do rectangle then print shaperef, we're going to print the length and the width. So this case, since we are printing out the contents of rectangle, we're going to print that the length is 8 and the width is 5. Now let's say we have the following lines of code. So now what we're doing is we're going to have the object of box, at least the address of the object, be stored in shaperef. So now shaperef points to an object of type box instead of type rectangle. So when we do this print statement and we do box and then print out shaperef, shaperef is actually going to print the length, the width, and height of the box object. So here we're going to print that the length is 10, the width is 7, and the height is 5. Now there is one thing we need to be careful with. So yes, a reference variable of some superclass type can point to an object of its subclass. So we get that. But that doesn't mean a superclass object is an object of a subclass. Okay, so let me just reiterate that or repeat that. So yes, we have a reference variable of a superclass type. It can point to an object of its subclass. But that doesn't mean that the superclass object is an object of a subclass. The superclass object is still an object of the superclass. What we're trying to say here is we can't automatically make a reference variable of a subclass type point to an object of its superclass. So we can have a superclass point to a subclass, but we can't automatically make a subclass reference variable point to an object of the superclass. Let's go back to the person and employee classes to show this issue. So remember, the employee is a subclass of the person class. So let's say we try to run a couple lines and see what would happen. Let's try this line, nameref equals employee. I think we did this in our earlier example. This line is perfectly fine. There are no issues here. And this is because nameref points to an object of its subclass. So in this case, even though nameref is of type person, we can have it point to an object of its subclass type. So in this case, we're having it point to an object of the employee class. That's my definition of polymorphism. We're okay with that. Let's try this line. So here we're trying to do the other way around. Employee ref is a reference variable of type employee, and we're trying to have it point to an object of type person, or in this case, the name object. Now we can't directly do that. We're going to have some casting issues. So we're going to try to typecast it to employee. So we're going to take the name object, typecast it to type employee, and then try to store an employee ref. This does not work. In fact, this is going to throw a class cast exception. And this is because we're trying to have the name point this is because name is pointing to an object of type person. We're not allowed to do this because here it does not refer to an object of type employee. The name does not refer to the employee class, because what we just said, we can't make a reference variable of a subclass type point to an object of the superclass. And here we're trying to make a reference variable of the employee class point to an object of the person class. We're not allowed to do this. So we can have a reference variable of the superclass point to an object of the subclass, but we can't have a reference variable of the subclass point to an object of the superclass. So this does not work. Now let's try this line. So we're going to have employee ref point to an object of name ref. And you might think, well, does this work? And the answer to that is yes, this is perfectly fine. But you might think, wait a minute. The second line, employee ref equals name, that's pointing to a person object, but name ref isn't that also pointing to a person object? Well, no, it's not, because here, if we're following the first line, name ref is actually referring to the object employee, which is of the employee class. So here we're trying to have a reference variable of the employee class point to an object of the employee class. This is okay because employee here is a reference variable of type employee. So we can have the subclass reference variable point to an object of its own subclass.